So there are three phases of a neuron, and the first phase is the resting potential. And it's what I described in the video before this. When a neuron is in the resting potential, there's more sodium and chloride outside, more potassium inside, and the inside charge is minus 70 millivolts more negative in comparison to the outside. This is done through three different forces that keep those ions in the locations that they're supposed to be in for the resting potential. And these forces are concentration gradient or diffusion, and basically it's what you learned in middle school, that molecules that are in areas of high concentration just naturally want to diffuse to areas of low concentration. Electrostatic pressure is that negative charges attract. So positively charged ions just automatically want to go to where the negative charged ions are, and vice versa. And then there is a third mechanism called the sodium-potassium pump. And this is an active mechanism. It's energy consuming. The other two are not. And for every 3 sodiums pumped out, 2 potassiums are pumped in. And you can see these three forces act on each of the ions differently. So sodium, because sodium is positive and because the outside is positive, and there's not a lot of it inside, by electrostatic pressure, sodium wants to go inside. It's positive. It wants to go to an area of negative charge. There's not a lot of it on the inside, so it also wants to go to an area of lower concentration. Chloride, on the other hand, because of electrostatic pressure, it actually wants to stay outside, but it wants to go in by the force of diffusion. Potassium, you can see, is on the inside. It's positive, and so through electrostatic pressure it wants to stay where it is, but by the force of diffusion it wants to go out. And then the sodium-potassium pump, which you'll see right here, is this little mechanism inside the cell membrane that is constantly pumping sodiums out and potassiums in. So those sodiums and those potassiums are sneaking across that membrane sometimes, but because, remember, the sodiums are dying to go in, so it's sneaking across, and the potassium might sneak across by the force of diffusion, but the sodium-potassium pump is keeping them where they need to be in the appropriate distributions.